All right, so as I alluded to at the tail end of that last video, the territory that we're moving into now is of when our second order differential equations are of the non-homogeneous form, right? So now they're no longer going to be set equal to 0. All right, so the techniques that we're going to learn, that you're going to learn over the next couple videos, is what we call the method of undetermined coefficients. Now, there are certain topics in mathematics that are harder to teach than others. And I think for differential equations, this is one of those that is a little bit harder to transfer than other techniques. So instead of me giving you a long drawn out a bunch of theory up front, which some of you know, if you've had me long enough, know that's not easy for me to not do, I'm going to jump in to a problem and we're going to learn as we go by making some mistakes. And I've chose some mistakes to make that that will help you along the way. But I'll be honest with you, a lot of this just comes down to a judicious guessing. How's that? Okay, so let's go ahead and try this problem. So it says find the particular solution to the following second order differential equation, and there it is. Notice as of right now we have this differential equation set equal to 3t. Now stay with me. Don't let me lose you in the beginning. So do you understand that there is some, so the idea of this, the game that we're playing, there is some function out there, some y of t out there. And this is interesting because if you take the second derivative of that function plus 3 times the first derivative of that function plus 2 times that function itself, what do you get? You get 3t. Now, more importantly, you can already see that you definitely want a strategy here. You don't want to try to guess that out. But let's focus a little bit more on the form of that right side of the equation. So 3t, I'm going to underline it here. So 3t is linear. Right, so this is a linear. And now what we're going to need is, so that's odd because if the sum of the first derivative or second derivative plus the first derivative plus the 0th derivative is somehow going to be a linear function. 3t is linear. Now, so as I said, we're gonna instead of doing the theory up front, let's take a guess. All right, let's take a guess of what's a good y of t to use. All right. Well, how about we just use, because we don't know what the coefficient would be either, how about we use a linear function? Well, let's see what that would look like. And now instead of using y of t, I'm just going to write y. Okay, that way we don't have a bunch of y of t's surrounded by t's. So let's assume that we take a guess and say, I don't know, maybe the form could look like this. Maybe this would work. All right, well, let's try it. So this is your guess, all right? And now let's make some mistakes because I don't know how else you learn in this game of mathematics without being able to make some mistakes. So let's go ahead and find out what y prime would look like and what y double prime would look like. Ready? And then we'll go back and compare it to what we have and see if we could make this work. So y prime, well, it's a linear function, so the derivative of y with respect to t would just be a. And of course, the derivative of a constant would be 0. So now, let's imagine for a second that we plug at in for the y, plug a in for y prime, and we plug 0 in for y double prime. Let's see what that would look like. Ready? So that would be 0 plus 3y prime. And that would be, wait a minute, what did I do? I don't know why I said plug it in and then I didn't plug it in. Let's try that one more time. So that would be 0 plus 3 times y prime, so that would be 3a, plus, well, 2 times y. So let's see what that would look like. That would be 2, then a, then t. All right. Now, that is what the left side would look like. We don't know what a is, but somehow we should get 3t from that, okay? Now, all I'm going to do is just write the original problem above. That way you see, for your notes, exactly what was plugged in where. And now I want you to take a look and see if there's any way that we could make this work. Well, that's not going to work. There's no way for you to make 3a plus 2at. There's no way for you to make that equal 3t. Right? That doesn't make any sense. You can't. These are not like these are not functions that you could combine. They're not like terms. I mean, we would need, in order to make that work, you would need a to be 0 as well as 3 halves at the same time, and then it would work. Do you agree with me? If you could somehow make if you could make this a equal 0, but make this a equal 3 halves, then it would work, right? But obviously we have laws of identity here, so we can't have a equal 0 while also equaling non-zero, not 0. So this is not going to work. Okay, well, let's get back to our guess here. So let's try, and this one will work. Let's try y is equal to, well, what else is linear? Well, how about at plus b, right? Now, that's still a linear equation, right? I mean, if you had y equals mx plus b, that would be a line. So let's take a look at what y prime would look like, and let's take a look at what y double prime would look like in this case. Well, likewise, when you take y prime, you would still get a, and y double prime would still be 0. But this is actually going to work. Ready? And let me go ahead and one more time just write the original problem here. And I'll show you how this is actually something we can use. Ready? So we're going to be plugging in for y. We're going to plug in for y prime, and we're going to plug in for y double prime. Let's see what that looks like. So that's going to be 0 plus 3a plus 2 times, ready, a t plus b. And that still has to equal 3t. Okay. Now, I think that I have enough space here to finish this problem because we're not too far from being able to do it. But I'm gonna just, since it's the first one from this section, I'm just gonna give us a blank page. And we're gonna finish it on this page right here. Okay, so let me get rid of these arrows. All right, now let's see what we can do here. So there has to be an A that we can choose, as well as a B that we can choose, such that 3a plus 2at plus b is equal to 3t. All right. Well, the way that we're gonna do this is we're first gonna go ahead and distribute this 2. Okay? So let me go ahead and do that right now. So let me rewrite it. So I'm not going to have the 0, so that's just going to be 3a plus, well, we're distributing, so that's 2at plus 2b is equal to 3t. All right, now notice that of our terms, this is the only term that has a t variable attached to it, right? This is a constant 2b, and this is a constant 3a. So let's put the constants beside each other, and then let's put the variable with the t by itself. Ready? So this is going to be 3a plus 2b plus 2at is equal to 3t. And now, so what do we want? What must happen here? Well, first let's address, obviously, since this is the only term that has a t in it, and notice that our solution has a t in it. So the first question you should ask is, what should a be, right, in order to make that work? All right, well then what I'm going to do is I'm going to take 2a and I'm going to set it equal to 3. Then I'm going to solve for a. Ready? Let's do that now. So I'm going to take 2a and set that equal to 3. All right, well, beautiful. That means a must equal 3/2. Now, that would work, but again, I still have this 3a plus 2b. Do you agree with me that I need that to zero out? Right? I need, if I can get this to zero out, as well as make a 3/2, that will work. So let's take a look at what we have. So I need 3a. Let me use a different color here. So I'm going to need 3a plus 2b. I need that to equal 0. I need that to zero out. But I already know that I need a to be 3/2. So this is 3 times 3/2 plus 2b. That's got to equal 0. All right, well, we can solve for b, right? We can 3 times 3/2 brought to the right side divided by 2. Well, if we solve for b, we would get b is equal to negative 9/4. All right, so how do we know that, well, 1, how do we know what we just did? And 2, how do we know that it is going to work? Well, the good news is you have a built-in check. So first, let me go ahead and write what our solution is. So the solution to this problem is y of t is equal to 3/2 t minus 9/4, right? That is your solution. If you wanted to double check that you did everything correctly, and you can do this on your own, you can take y prime, take y double prime, then plug those in to our equation and see if, when you add everything up, see if you get 3t, right? Okay. So you can try that on your own. Here's the takeaway before I go to the next problem. It appears that if f, remember, it's always the second order equation set equal to an f of t. It appears that if f of t is linear, right, then a good choice we're going to go with some type of y is equal to at plus b, right? So what did I just say there? Maybe you followed me through everything else and you missed that last part. So you're collecting some information. So if the right-hand side of the equation is linear, like 3t, then right now we're going to be thinking this is a good choice to use for y. Okay, at plus b. All right, let me see how much space I got. Yeah, I got plenty of space. Let's go ahead and try another one. All right, so in this example, we're going to have y double prime plus 3y prime plus 2y. Let's see what it's equal to. Well, it's equal to 10e to the 3t. All right. So the game right now is to take a guess of the form of y. All right, now let's think about this for a second. So clearly, first thing let's notice is obviously that is not linear. So you do not want to go with at plus b, right? That's not going to work. This is not linear. But as we start to consider some things, just imagine that you're going to have to take the second derivative and the first derivative of whatever you choose for y. So we would need a function where it doesn't change. The derivative doesn't change the function. That's still sloppily said. What I'm really alluding to is I would be thinking something like e to the x, right? And that's only because the derivative and second derivative of e to the x is still e to the x. So that's the way that's where my mind would be going. So let's think about a good choice for y. So how about well, let's see, if we have e to the u, right? Because we don't have just e to the x, we have e to the u. We know that that's just chain rule, so it ends up being u prime times e to the u. So in that case, if we let y equal, well, how about a e? Now, we don't want to use another. So do you agree with me let me just write something really quickly. If I have e to the 3t for y, when I take my first derivative, I'm still going to have an e to the 3t in there. When I take a second derivative, I'm still going to have an e to the 3t in there as well, right? Because it's always u prime times e to the u. So in that case, because of that, what I'm going to want is some a, that's the part I don't know, but I do know that I want the exponent to be e to the 3t. All right, so let's now take a look at what our derivatives would look like. So let's start. Well, if you take your first derivative, that's just going to be, if you let u be 3t, then u prime would be 3. So that's 3a e to the 3t. And what's y double prime? Well, that would be, again, u being 3t, u prime is 3, so that would be 3 times 3, or 9a e to the 3t. Okay. So what I'm going to do right now is just rewrite this guy, and then I'm going to plug in and see what happens. Okay, so let's make that just a little bit smaller. And now I'm going to just draw you some quick arrows. So we're going to see what happens if we plug in for y, plug in for y prime, and plug in for y double prime. So let's see. Ready? So I'm going to kind of work. I don't want to fit too much in. Let's see. I think I have enough room. So let's start with y double prime. So that's 9a e to the 3t plus 3 times y prime. Now y prime is 3a e to the 3t plus 2y, and we chose y to be a e to the 3t. So I am running out of space, so let me grab that. So let me grab that and bring that down here. And now let's go ahead, and that was going to be equal to f of t, which is 10e to the 3t. Okay. So what's going to happen right now is we're going to clean this up a little bit. We're going to go ahead and distribute the 3, distribute everything out and see what it looks like. So I can drop my parentheses. This is going to be just 9a e to the 3t. If I distribute my 3, this is going to be plus 9a e to the 3t. And if I distribute my 2, that's going to be plus 2a e to the 3t. Right? And that still has to equal 10e to the 3t. Okay. Now, each of these are like terms, right? They're all a e to the 3t's. So then what I can do here is I can simply write that as 9. You think of it as factoring out an a e to the 3t. And I would be left with 9 plus 9 plus 2 a e to the 3t. Right? So all I did was factor out an a e to the 3t out of each one of these. Now I purposefully chose, normally when we factor out, we put the part we factored on the left side, but I purposefully chose to write that on the left side because we are going to compare that to the coefficient on the right side of the equation. So it's 9 and 9 is 18 plus 2, that's 20. A e to the 3t has to equal 10 e to the 3t. And now my only question to you is, what should a equal to make that work? Right? Well, yeah, absolutely. A would have to be a half. Half of 20 is 10, and then the equation matches perfectly. Okay, so now listen, that's perfect. If on a quiz or a test, if you find out what a is, that's perfect. But you weren't asked to find what a is. You were asked to find what y of t is equal to. All right, so let's go back to the previous page and let's highlight, let's go back to the above, this page. Let's go ahead and, this was your guess. A e to the 3t, but you now know what a is. So let's write it. So this should be 1/2 e to the 3t. So as I was just saying a second ago, always remember to plug in to your general solution, or your solution, I should say. There it is. So if you wanted to, you could take a second and take the y prime, y double prime, and then you could go back and plug y double prime in, y prime in, and then plug 1/2 e to 3t in for y. Plug everything in, combine all like terms, and see if it does indeed equal 10e to the 3t. Okay, so what's the takeaway? So the takeaway is when f of t is of the form, say e to the u or a e to the u, then you want to choose a y that is of the form of, say, A, E. I won't write A 2 times that way, so let me rewrite it this way. So if f of t takes on the form of, I'm going to use a different letter, so b e to the 3t, then you should probably be thinking of a y that is of the form of also of the form a e to the 3t. Okay, I hope that makes sense. And now let's do one more example, and then we'll take a break and I'll finish up this section in the next video. So example that we're going to do is of the following: y double prime plus 3y prime plus 2y must equal, a trigonometric function, sine of t. All right, so there's some y out there that if you take its second derivative plus 3 times its first derivative plus 2 times itself should give you sine of t. All right, so here's that game of guessing. So what is a good y to use? Well, let me come off to the side. Let me make some mistakes here. So what if you just chose a sine of t, right? Don't write this because I'm going to erase it in just a second. What if you chose that? Why would that not work? Well, you got to think about, as soon as you start taking the derivatives of sines, you end up with cosines, right? So clearly we're going to need more than just a sine. In fact, let me go ahead and tell you what we are going to need. Well, this here is going to work. A sine of t plus b cosine of t. Now, why not a sine of t minus b cosine of t? Or why not negative a cosine of, or sine of b minus b cosine of t? Good questions. As of right now, this is going to be the form you're going to want. Okay, but again, that's why I said there's a little bit of guesswork here. All right, well, you know what to do. You've guessed a y. You have a potential y. And to that, we need to try taking y prime and y double prime, okay? Because we need to make sure we can get this to work. Well, how about, well, let's go ahead and take the first derivative. So the derivative of sine is cosine, so this is going to be a cosine of t. Now, the derivative of cosine is negative sine, so that's going to be minus b sine of t. One more round of derivative. So now the derivative of cosine is negative sine, so that's going to be negative a sine of t. And the derivative of sine is positive cosine, so that's negative still going to be there, so it's negative b cosine of t. All right. Well, this is going, I don't know that I'll have enough space on one line to do this, but what you would need to do now is plug in, I'll draw you an arrow. You're going to need to plug in for y double prime, plug in for y prime, and my apologies for writing right through that. Let me go ahead and rethink about that, rethink that before I do that. So a sine of t plus. Okay, so without drawing through the proposed solution, so plugging in for y prime and plugging in for, for y double prime, and then plug it in for y. Okay, so now let's see what happens if we were to go down this route. Okay. So ready, I'm going to open up some brackets, and it's y double prime, right? The original problem is y double prime. I'm all over the place here, look at me. Plus 3y prime plus 2y. So let's get to it. Let's start plugging in. So y double prime, in this case, would be negative a sine of t minus b cosine of t. All right. Now, to that, it's plus 3, and now it's going to be times, well, now let's plug in y prime. So that's a cosine of t minus b sine of t. Okay, now, bear with me, because what I'm going to do is I'm going to see if I can make this work here. So if I cut that and then paste it and make it a little bit smaller, hopefully you can still read that. And let's keep going. So that's going to be plus 2 times, well, now let's plug in y. So that's a sine of t plus b cosine of t. Ready? One more round of cutting and pasting so that I can shrink it a little bit. All right, and that has to be equal to just sine of t. All right, so is this going to work? Well, let's find out. So what I'm going to do right now is distribute, and I'm going to, well, let me go ahead and distribute. Let's start there. So this is going to be, and I'm going to drop all these brackets. So this is negative a sine of t minus b cosine of t plus 3a cosine of t minus 3b sine of t plus 2a sine of t plus 2b cosine of t. Okay, now I know that it's equal to sine, so I'll get us there in just a second. So what we're going to do is we're going to write anything that has a sign, any variables with a sign, we're going to go ahead and cluster them together, and anything with a cosine is going to get clustered together. Okay? So I know that you might be able to skip this step. Not skip it, but I know that you might be able to do some of this in your head, but I want you to have some good notes for this problem. So let me go ahead and cluster them. So that's negative a sine of t plus 3a. No, my sincere apologies. So, okay, so let me see other sign. So minus 3b sine of t. And what else has a sign in it? Plus 2a sine of t. All right, so let's focus on that part right now. Are you with me that all I'm doing is I literally just rewrote, dragged and dropped anything with a sign beside each other. Okay, so if I factor out a sine of t, let's see what's left. So this would be negative a minus 3b plus 2a, and then of course I factored out a sine, so that would be sine of t. All right, now I can combine a positive 2a and the negative a such that I get a minus 3b sine of t. Okay, so we're on to something. Let me go ahead and give myself a fresh page here. And I'm going to make that a little bit smaller. Okay, ready? So now let's see if we can rewrite anything that has a cosine. So let's bring anything with a cosine and write that beside each other. All right, so that's going to be negative b cosine of t plus 3a cosine of t, and finally plus 2b cosine of t. All right, so now you can imagine I'm factoring out a cosine. And what's left when you factor out a cosine? Well, let's find out. So that should be negative b plus 3a plus 2b cosine of t. All right, so just like in the previous one, if I have 2b here and a negative b here, I can combine those. So that's going to end up leaving me with just positive b plus 3a cosine of t. All right. So are you with me that this was all equal to sine of t, right? So now let me rewrite this equation now that I've simplified it. So here it is. So I have a minus 3b sine of t plus b plus 3a cosine of t, and that has to equal sine of t. All right. So if you're with me so far, awesome. We're almost done with this problem. Just bear with me. Bear with me. So in order to make this work, right, I need to find an a and a b out there, right? So in other words, a has to equal something, b has to equal something, but such that when I plug them in here, I get sine of t. All right, so let's see what we can do here. Well, looking at my answer, the right side of the equation, all I have is a sine. So I'm definitely going to want this whole term to zero out. Does that make sense? So that b plus 3a, I need that to zero out. That's got to equal 0 so that the cosine disappears. All right, and then I have, well, let's say a minus 3b. What would I want that to equal? Well, so stay here, look at me real quick. What is the coefficient that's attached to this sine variable? Say it out loud. Say it. 1. So this is 1 sine. So if I can get this to zero out, then I'm going to want this a minus 3b to equal 1 so that I have 1 sine. Does that make sense? Okay, so I know that I want to set this equal to 1. What is that? Well, we've been down this road before. That is just a system of linear equations. Now you go through, you solve your system. First off, it's probably better to write it as, get the a's under each other and the b's. I think I just switched them places, didn't I? That's okay. So as long as 3a plus b has to equal 0 and a minus 3b has to equal 1. Okay. So all I did was I wanted the b's to be beside each other and the a's to be beside each other or under each other so that I could do my system. So from here, I don't care if you use a matrix or if you do some substitution, elimination methods. What you would find out is that A would have to equal 0.1 and that B would have to equal negative 0.3. Okay, if you have that, then it would work out perfectly. So what is your answer? So y of t. Okay, so remember, once you know what to plug in for A and B, sometimes you get confused and you start thinking, well, wait a minute. I now know what A is, I now know what B is, but where am I going to plug them into what? Well, you always, when you're writing your answer, remember y we said was A sine of t plus B cosine of t. That was our guess for y, and we got it to work. So just make sure that you're plugging the A and the B in for your y equation. So let's go ahead and write this answer. So the answer to this is y is equal to that's a 0.1 sine of t plus, no, that's going to be minus because B is negative, minus 0.3 cosine of t. There it is. That is your solution. You could always take the first derivative and the second derivative and go back and plug them in to this original problem and see if everything combines to get sine. All right, so that's enough. That's enough for this first video. I'll see you in a bit.